Welcome to the Explainer. Now, if you've ever built a backend, you already know that your database is the absolute bedrock of your application. But treating that database like a public-facing product, yeah, that is a recipe for disaster. Think of your raw database data kind of like crude oil. It's incredibly valuable, absolutely essential, but completely unusable to the end consumer in its raw, unrefined state. It has to go through a refinery. It needs to be filtered, processed, and polished before it becomes high-octane fuel ready for a vehicle. So today, we're going to look at exactly how to build that refinery. We're going to explore the critical transformation path that takes raw storage entities and turns them into secure, scalable, and consumer-ready API endpoints. Let's get into it. Here is our architectural blueprint for the next few minutes to move your codebase away from messy coupling. We'll cover the API anti-pattern trap, bridging two distinct models, the four-stage refinement pipeline, and finally, automating those transition layers. Okay, let's dive right into Section 1, the API anti-pattern trap. We are starting with arguably the most dangerous pitfall in back-end engineering. We call this the one-to-one anti-pattern. Now, it seems like a brilliant shortcut in week 1 of development, right? But by year 1, it's the exact reason your team is crying into their keyboards at 2 a.m. trying to untangle everything. It happens when an engineering team decides to expose their internal database schema directly through a public API, without an intermediate abstraction. Essentially, whatever tables and columns exist in your database are exactly what your API returns to the client. Taking this direct one-to-one shortcut from your database straight to your user is a massive, massive architectural trap. When you pipe raw database access directly to a mobile device, it creates an incredibly brittle system. Every single time you tweak a database column to optimize storage, you instantly break the mobile apps relying on that exact structure. Plus, there is a severe security risk here. You're essentially leaving the front door to your database wide open. But if you implement an API layer, a true separation of concerns, you create a secure gateway. You map the data, you handle authorization, and you manage caching. It transforms an open door into a heavily guarded, highly efficient toll booth. So let's shift focus to Section 2, bridging two distinct models. To really understand why treating your database exactly like your API is fundamentally flawed, we need to examine the underlying mental models of both systems. On one side, we have the database. Its entire core objective is storage optimization. It thrives on normalization rules and relational efficiency. It literally wants to break data apart to avoid duplication. But then we shift gears completely. On the other side, we have the API, representing the presentation layer. Its core objective is consumption simplicity. It prioritizes performance and security. The API doesn't care at all about storage efficiency. It just wants to deliver a neat, consolidated package of data so the client app doesn't have to do any heavy lifting. We're dealing with a profound comparative duality here. And this brilliantly illustrates exactly what we're talking about. The fundamental building blocks of your data model are tables, along with primary and foreign keys. But the second you cross over into the API model, those concepts simply vanish. They have to be translated into JSON payloads and clear, human-readable endpoint names. You're moving from strict normalization rules on the storage side to resource-driven abstraction on the presentation side. All right, Section 3, the four-stage refinement pipeline. So how do we safely and reliably bridge this gap? Well, we use a four-stage refinement pipeline. We start with resource mapping, move into establishing strict data contracts, execute DTO translation, and finally, endpoint routing. Let's break down exactly what happens at each of these stages. Step 1 is resource mapping. In a highly normalized database, a user's information might be scattered across 3 separate tables: users, profiles, and settings. If you expose that one-to-one, the client application has to make 3 separate network requests just to render a basic profile page. And honestly, that's terrible for performance. Instead, we use a resource aggregator. By grouping these heavily coupled tables, we funnel them into a singular, unified REST resource. So a single logical JSON payload accessible at, say, /user profile. This completely spares the client from having to orchestrate complex multiple requests. Once we know what the payload should conceptually look like, we move to Step 2, defining data contracts. Think of this as building a rigorous validation gate. We use standards like JSON schema to explicitly declare exactly what is allowed through. We aren't just saying, hey, send me data. We're strictly enforcing data types, like ensuring an age is an integer with a minimum value of 18. We enforce formatting rules for emails, and we clearly dictate required properties, ensuring a user ID and email are always present. Absolutely nothing gets past this gate unless it perfectly matches the contract. Now, step 3 involves the actual translation, leaning on the absolutely crucial use of data transfer objects, or DTOs. DTOs are objects implemented directly in your backend code. They act as the ultimate filter. Your database model contains things that should literally never see the light of day: password hashes, internal record tracking IDs, system timestamps. The DTO takes the raw database model, aggressively scrubs away all of those sensitive internal fields, and passes forward only the safe, clean data that fits the contract we just established. It's a non-negotiable security layer. Once those first 3 steps are done, step 4 is beautifully simple. We expose the CRUD matrix. Now, what's really interesting about the setup is how it acts as a literal decoder ring between your backend database operations and your front-end HTTP network requests. We map create directly to post. Read maps to get. Update gives us put for full updates or patch for partial updates. And delete maps straight to the delete method. It takes the deeply technical actions of your database engine and exposes them as clean, standardized, stateless HTTP methods. When we zoom out, we can see how these 4 stages act together as a unified factory floor. Raw, unformatted data blocks enter on one side. They're grouped in resource mapping, validated by data contracts, scrubbed of sensitive fields by DTO translation, and finally packaged and shipped via endpoint routing. The result exiting the pipeline is a perfectly structured, secure API response. Our crude oil has officially been refined. Finally, Section 4, automating the transition layers. Now, manually writing the code for all of those transition layers creates a massive development bottleneck. Nobody has time for that. So to scale this, we look to the acceleration ecosystem landscape. Because this refinement process is so standardized across the industry, an entire ecosystem of specialized tools has emerged to handle it for us. We can map these tools across 4 distinct automation quadrants, balancing the level of architectural complexity against the level of automation, ranging all the way from manual coding to instant push-button generation. Let's quickly distill the specific functions of these 4 tool categories, paying attention to how they accelerate development. First up, object relational mapping, or ORMs, like Prisma or Hibernate. These rapidly abstract away raw database queries, converting your tables directly into native code objects. Next, we use schema generators like QuickType to completely automate code compilation, instantly translating JSON schemas into static types. Then, design-first generators like Swagger and OpenAPI step in. You define your spec file once, and it automatically stamps out your server routers and client SDKs. And finally, for absolute blazing speed, auto-CRUD APIs like Postgres or Hasora hook straight into a database to instantly auto-generate fully functional REST or GraphQL APIs without writing a single line of boilerplate. Let's move on and see how this builds, mapping these exact automated tools perfectly back onto our 4-stage refinement pipeline. Schema generators slot right in to handle the contracts phase. ORMs slide in seamlessly to manage the DTO and database translation. Design-first generators wrap entirely around contracts and routing. And those incredibly fast auto-CRUD tools like Postgres, they effectively blanket the entire pipeline, automating the bridge from resource mapping all the way through endpoint routing in one sweeping, effortless motion. And that brings us to the fully scaled industrial blueprint of a modern API layer in production. This is what it looks like when you deeply respect the separation of concerns. Raw database entities sit isolated at the bottom, perfectly optimized for storage. Through our structured refinement pipeline and modern automated toolchains, those raw materials are safely extracted, grouped, validated, filtered, and routed all the way up to the top. The ultimate result is a layer of clean, consumer-centric network endpoints, GraphQL gateways, and microservices meshes. It's scalable, it's robust, and most importantly, it is secure. Which leaves us with one final, provocative thought to consider as you evaluate your own architecture. When your users make a request, are they crossing a carefully designed, highly filtered, secure bridge? Or have you just left an open window pointing straight at your database? The difference between the two isn't just a matter of clean code. It's the fundamental difference between a system built to scale and a system just waiting to break. Thanks for joining me for this explainer, and I'll catch you in the next one.